And away we go. 8.5 variation functions. While building skateboard ramps, it has been determined that the best ramps are the ones in which the length of the top of the ramp is 1.5 times as long as the height of the ramp. As shown in the table, the length of the top of the ramp depends of the height of a ramp. The length increases as the height increases, but the ratio remains constant. Now, what does all that mean? We're building this ramp. We have the length to height. So the length is right there, the height is right there. So the best is when the ratio between those two is 1.5. In other words, when you take the length divided by the height, it's always 1.5. If you want to build a little taller one, you do 6 divided by 4. You want to go higher, 9 divided by 6. But as long as you keep that ratio as 1.5, it's a nice ramp, apparently. Now notice that these increase and these increase. If they increase together, we say that this is a direct relationship. They are doing the same thing, so it's direct. Now it also says the equation L over H equals 1.5 can be written as, well, you can multiply both sides by H. So L is equal to 1.5H. So there's different ways you can write this relationship. Not a whole bunch, but there's a few you can write it, or a few ways to write it. How variables relate to each other. Direct definition, where both variables increase or decrease together. So they either both decrease together or they're both increasing together. That's a direct relationship. When one variable increases and the other decreases, that's an inverse. So one is increasing, the other one is decreasing. That means you have an inverse relationship. Now the equations that go along with that is y equals k times x. Now we will find the k. That's a number. So k is not really a variable, it's a number. Now if it's an inverse relationship, then it can be written like this, y equals k over x. So we multiply if it's direct, we divide if it's an inverse relationship. What does this say? If you graph them, y equals 3x, a direct relationship, looks like a line. An inverse relationship looks like a hyperbola, it's called. The relationship given by L equals 1.5h is an example of a direct variation and can be expressed in the form y equals kx. K is the constant of variation. So how do I find the k? Let's go to an example. What if it said this? If y varies directly as x, this statement right here, just this piece, says I can write y equals k times x. Just that part right there. Then it gives us some values for x and y so that we can find k. It says y is 15 when x is negative 5. So we can plug 15 in for y, negative 5 in for x. And now it says find y when x equals 7. But first we're going to find the k. We're going to divide by negative 5. K turns out to be negative 3. We needed that to solve the rest of it. Now we can write this equation right here as y equals negative 3x. We found the k. So the first piece of information is usually find the k. The last piece is to use it. Find y when x is equal to 7. So our final answer is negative 21. In other words, y is negative 21 when x is 7. So find the k, use the k. That's all we're doing. Find the k, use the k. Suppose y varies jointly as x and z. This right here is a little, well, it's the same thing. It's y equals kxz. So now what we're going to do is find the k and then use the k. Let's find it. When x is 9, and z is 2, suppose find y, oh, wait. Oh, well, they gave the information kind of backwards on this one. They want you to use the k, and then they give you information to find. So we actually use this, we use the second set first in this case. They gave it to us a little differently. So x is 5, z is 3, and y is 20. So they gave us everything except for the k in the second set of numbers. So 20 equals k times 15. So k is 20 over 15. So you multiply, do a little division, and you can divide each of those by 5. So k is 4/3. So y, is it y first? Yep, that's how they gave it to me. Y is 4/3 xz. That information right there allowed me to find the k, and now they want me to use the k. Find y when x is 9 and z is 2. Well, we can do this. We can say 9 divided by 3 is 3. 4 times 3 is 12, times 2, 24. Find the k, use the k. Sometimes they give you the information a little out of order. If one quantity is increasing while another quantity is decreasing, in other words, the number of miles in your car is going up and the amount of gas in your tank is going down. So that's an inverse relationship. That's a real simple example of what inverse could be. If one quantity is, then it's an inverse variation is expressed in the form y equals k over x. K again is the constant. So now if y varies, this should say inversely, as x and y, as x, y equals k over x, that's inversely. Y equals 15 when x equals -5. So find the k, and then we're going to use the k. And in this case, we have to multiply by -5. Multiply by -5. So k is -75. Well, now we can rewrite that equation. We can write y equals -75 over x. Now they say find y when x is equal to 7. So it's just -75 over 7. I mean, you could probably divide it and give a decimal, but I don't really care what it is. Unless it was a story problem, then we might care. State whether each table represents a direct or inverse variation, then name the constant of variation. 4 to 8, 8 to 16, 16 to 32. Are the values increasing or decreasing? Increasing, right? Let's see what the others are doing. So here to here, 24 to 48, 48 to 96. So increasing and increasing as you go down the chart. That means it's a direct variation. Direct, and it wants to know what's the constant. So if it's a direct variation, then y equals k times x. You multiply on direct, k times x. We have 12 is equal to k times 4. So k equals 3. So the k is 3 in this case. The constant of variation, they call it. And I know that you spell constant with a C, but they usually use k for that constant, believe it or not. These values are increasing as you go down, and look how this is decreasing. So this is decreasing. That means we have an inverse relationship. It varies inversely. One's going down, one's going up. Now that's y equals k over x. So you divide on that one. Multiply with direct and you divide on inverse. Now I wouldn't use the decimals, I would use the nice numbers. So 3 is equal to k over 14. We have the x and we have the y. You multiply both sides by 14. And you get k is 42. K is 42. Last one. 0.2, 0.6, 1.8, that's increasing. 2472, that's definitely increasing. So we have a direct. We have y equals kx, you multiply with direct. and I don't know, I can't avoid decimals here, but 24 is equal to K times 0.2. So K is 24 divided by 0.2, whatever that is. 24 divided by 0.2. 120. So K in this case is 120. Now, no matter which one you pick, K should be 120, or it's not actually a direct or inverse relationship. The table shows the times it takes to bicycle 12 miles at various speeds. The speed is decreasing, so the time is increasing. So this is decreasing, so the time is increasing. As you slow down, it's going to take you longer to get there. That's an inverse relationship. Does the time t vary inversely or directly? Inversely. If you're going to slow down, it's going to mean more time. Write an equation relating t and s. So speed and time, we have time and speed, so let's go with time is equal to k over speed. They're an inverse relationship. Write an equation, but you got to replace k. K is not a variable, k is a number. So we need a number there. So you can pick any one you want. If time is 1 is equal to k over the speed is 12. Multiply both sides by 12, and it turns out that k is actually 12. If k is 12, then the equation is time equals 12 over speed. So that's the answer to that question right there. You got to have the equation with k filled in. T equals 12 over s. What time corresponds to a speed of 4 miles per hour? So time is equal to 12 over 4. I'm going to put the 4 in for the speed because it's miles per hour. So the time is 3 something. What is it going to be? 3 hours. So we found the K, we used the K. State whether each item is an example of direct or inverse. The length of the side of a square and the perimeter of the square. What happens if I increase the side of a square? What's going to happen to the perimeter? They'll increase, won't it? So they'll both increase. This is a direct relationship. Number 2, that's how you write direct. That's multiplication. Now number 3 might be the tricky one, but on direct and inverse, we don't have the variables on the same side. So what we could do on this one is divide by x. So y equals 8 over x. So anytime the variables are multiplied, that's actually an inverse relationship. So this is, we can get this to look like the inverse equation. Get one of the variables with the k, with the constant, with the number. Increasing, right? 0.512, and as you work your way down, this is decreasing. So this is an inverse. That's all they're asking. Is it direct or inverse? That's inverse. Now on this last one, you could make a list of the x's and a list of the y's. And you could grab these points. You could say, well, I have a point at 1, at 2, at 3 and 4. 3 and 4. And then the y values are going 2 at these points, 4, 6, and 8. So increasing and increasing. They're both increasing at the same time. So this is a direct relationship. Any questions on any of this? Awesome. Let me stop.